My name is Vladimir. I'm working for Elcom Soft, a Russian company, for about 20 years. We have 25 people on our team, some are researchers and developers and so on. And everything we're doing, we're cracking for food, in other words, writing the password recovery software mostly. Today I'm going to tell you about our research on smartphone forensics. Some of this research, just a little bit, is being used in our current software, and some of this is really fresh and new, and the research is still in progress, and we're still working on it. I'll concentrate just on three types of the smartphones, BlackBerries, iPhone, and Windows Phone. We didn't take our hands on the Android devices yet. That now have a huge part of the market, probably about 60%, but the problem is that nobody in our company really loves Android. I'm really sorry for Android users. I'm mostly using the iPhones, probably 90% of our team. That's just probably historically. So one of the tasks we're experiencing in our work is forensic analysis of the smartphones. They contain a lot of important data, the mission-critical data, I would say. Not only personal, but business as well, because most of you obviously have your corporate email on your iPhone, your contacts and notes and a lot of other information. And so when it comes to the analysis of the smartphone contents, there are a lot of methods of how to get as much as you can out from the smartphone. The people doing there are mostly working for forensics companies, for government, for police. For example, just a quick case we experienced it about 2 years ago. You probably remember the tragedy in Norway when Breivik killed about 100 people. And the same day in the evening, we have received an email from the Norwegian police asking, can we provide any help to extract information from the iPhones from the people who were killed. Many of them, of the smartphones, I mean, have been protected with a passcode, and to identify the victims, they were needed to break the passcode and get personal information out from there. And we provided them with our software for cracking the iPhone passcode and to get information from there. So for different platforms, there are different methods available, starting from the logical acquisition, which is the simplest probably method, and just by connecting the cable to the smartphone and to the computer and running some software that gets information out of there. For iPhone, there is a kind of logical acquisition called advanced logical. That's not an official method, and it requires a lot of experience, and I will tell you more about that. It is really similar to the simple logical, but gets more information out there. There is also physical acquisition, and which gets more from the smartphone. There is chip-off method, when you just extract the memory chip out from the iPhone. It is destructive, actually. You won't be able to repair your device after that, but you'll get the complete memory dump of the device. You can also create just a local backup of the smartphone. Most of the vendors provide special software for that. And for iPhone, there are a few additional methods of extracting information. First of all, you have the complete backup in the cloud. Of course, if the appropriate setting is set on the iPhone. And also, there is a feature introduced in iOS 7 called iCloud Keychain, which allows you to upload some of the private information, like the passwords to websites, after complete information, and even credit card number. There's special storage in the iCloud. It is additionally protected by the special security code and sometimes with a two-factor authentication. But still, information is there, and sometimes it is possible to extract it. Also, most systems can store the documents in the cloud. I'm using it all the time, for example, making the presentation on my home Mac computer and uploading it to the cloud. Actually, I'm editing it right in the iCloud, and then I have it here on my iPad and on iPhone as well, and accessing from everywhere. This document, those documents can also contain a lot of information interesting for those who perform forensic analysis. And finally, there is a location service for most of the platforms, just not for BlackBerry, but it is available for Android as well, which allows anyone to detect your almost exact location using GSM and GPS services. I'll start with the iOS and briefly describing how it is being done. The logical acquisition for the iPhone is quite simple. It's just performing the backup using the iTunes. Device must be unlocked, or you should know the passcode, and it is possible that backup created by iTunes will be password protected. The password protection is not just the property of the file, like for Windows, for Microsoft Word or Zip or Hive or anything like that. Actually, the password for iTunes backup is a property of the device itself. So once you set the backup to the iTunes, the same password will be used for all backups created on all computers. And backup password is stored inside the iPhone, and it is not possible to get it from there, but only with the physical acquisition by performing the full physical dump of the iPhone, which is really complex. And the password protection is good. The password is hashed using PBKDF function with 10 or 20,000 iterations, and even on the GPU, the password cracking speed is really low. So if you got the password protected backup, it won't be easy to break it. With the physical acquisition, this method is preferable because it gets much more from the iPhone. But it was possible to make it only for devices up to iPhone 4 that had the boot ROM style jailbreak. And so it was possible to perform the complete physical dump even without the knowledge of the passcode. The passcode just protects some of the information, like the keychain and the mail, but the rest you can get even without the passcode. For A5 and later devices, so starting from iPhone 4S, including the latest iPhone 5S, there is no boot ROM jailbreak, and so you can perform the physical acquisition if the user mode jailbreak is installed already, or if the device is not passcode protected, and so you can install the jailbreak itself. Advanced logical acquisition, it can also be performed usually when the device is also unlocked and you know the passcode. What it does, it doesn't use the iTunes. It directly connects to the special service running on all iPhones on a dedicated port. And there is a special protocol talking to this service and sending the commands to extract information from there. I will tell about that more. And finally, for the iCloud, if you know the Apple ID and password, you can get the complete backup of the device from the iCloud, of course, if the backup is already there. The main advantage of this method is that you don't need to have the device itself. You only need to know the Apple ID and password. And the backup stored in the iCloud is almost the same, I would say 99% as the local backup. And also, the documents might be stored in the iCloud, and some application data and location data as well. Backup contains almost everything what is inside your iPhone. You can create it yourself using the iTunes, and for iCloud backup, the backups are performed every day, not more frequently than once a day when the device is connected to Wi-Fi and power source and the screen is locked. And here is the screen. I'm not sure how it is visible. The backups created created by iTunes or by iCloud use their own special format, which is encrypted, and you don't even see the file names of the data which is stored on the iPhone. But on the market, there is quite a lot of tools, both free and commercial, which can analyze both types of the backup and show the complete file system of the iPhone. Here is a screenshot of one of them. You can get all the device information, SMS messages, contacts, and so on. But actually, there is more than that, and interesting for some organizations, I would say, that analyze the iPhone contents. For example, you get the application data for all Google applications which you were using. You get the data from the social network, from Twitter, Facebook, WhatsApp, and so on. There is also a keyboard cache, which keeps almost everything you type on your keyboard. It is saved in a few different files in almost plain text format. And there is also maps data. There is your voicemail. There are message attachments. And probably you don't know that when you delete your iMessage conversation from the iPhone, the pictures which were attached to incoming or outgoing messages are still stored there on the iPhone. There is no way to extract them using just the standard tools, but if you perform the complete copy of the file system, you will find in a separate directory all the images that were attached to the messages. There is also a quite comprehensive list of all the Wi-Fi access points you even connected to in your life, and it isn't possible using the iOS features to delete those entries. And they also store some parameters of these access points, as well as the last date and time when you even connected to. Next, the frequent location data. You probably remember the scandal about three years ago when it was said that Apple collects all information about your movements. Actually, Apple just keeping the database of the GSM and Wi-Fi access points you connect to make it faster to connect next time. But in the iOS 7, now this information is stored for 50 days only, and then it is replaced with more fresh data. But still, there is a lot of data collected, and you can see the map of my location where I moved, and the first item is home. I never said that it is my home, and somehow Apple detected that it is my home address. And for all the location, the exact time is recorded when I came to this place and when I leave. Here is the database with the location data stored in the iPhone. You won't be able to get it using the backup at all. You can only extract it using physical expedition or advanced logical, and you will also have for advanced logical to install the additional program which will allow to perform a more complete file list from the device. So you can see the tables for the Wi-Fi access points, for GSM, for LTE, and so on. And there are exact location of all those Wi-Fi access points, even those you haven't connected to, just once your device ever seen, and with the exact location of this point, and with some additional information on that. And this information may allow you or investigator to retrieve the complete map of your movements from your smartphone. Another story is, you've probably seen the device on the Black Hat. It is a very small device which looks like a simple charger, but it is not a charger. It is just a device with a USB port, and once you connect to it, this is actually a very small computer based on the Beagle board. And what it does is it is using the The same protocol as iTunes use for backup. It's not charging your device, but just extract everything from your iPhone as soon as you unlock it. And it doesn't matter that it has a passcode. You just trust this charger. With the iOS 7, it has been improved a little bit. And once you connect to the USB port and the device detects that it's not a simple charger and there is something behind it, it asks you whether you trust this computer, and only after that the trust relationship will be established. But still, many people don't pay much attention to that and just click trust, and what happens next, this device behind it can extract almost everything from your iPhone and decrypt it. Here is how it's being done. If you press trust, the iOS creates a pair of records, of encryption keys, which are stored on both the computer and the device. Here is the location where they are stored. You can check this on your Mac computer, for example. And here is the screenshot from my Mac. I have connected a lot of iOS devices to it. And then, if you connect to the lockdown service lockdown daemon, you can send a command to perform the complete backup the same way as iTunes does. You can install any software to the device without the knowledge of the passcode. You can get complete device information, synchronize data, make the screenshot of the device, get the device diagnostic information, and even put the device into recovery mode. This is like a backdoor in iOS-based products. So for jailbroken devices, you can get almost all the contents of the file system. For non-jailbroken one, it is a little bit less. But still a lot of interesting one, which is not available in a plain backup. And it works even if the device is passcode locked, and you only need the parent record you can get from the computer and use this parent record on any other computer. And once the device is paired, you can even connect to this service using not the USB cable but over the Wi-Fi, and probably even through the 3G networks. We don't know. Next, let's go to the iCloud. Here is the iCloud control panel. It is available on both Mac and Windows, and you can see what items are synced with the iCloud. And if you go to backups, you'll see a list of devices and the time they were last backed up to the iCloud and the sizes of the backup. But all you can do with the iCloud backup is just restore a new device from it. Apple doesn't provide you any other feature to retrieve the information from the backup. And it isn't possible to make it from the iTunes. It can be performed, the backup itself, only over the Wi-Fi. So how we have reversed it? We have installed the jailbreak on the iPhone, and then we installed OpenSSH, get the keychain over the iPhone, and then performed, deleted the iCloud settings, made the reset, rebooted, and then we set up the proxy. So from now and then, iPhone connects to all networks using our proxy, and replaced the keychain in the iPhone with our own one, and replaced the trusted root certificates. So now we'll be able to read all the traffic by decrypting all the packages. Technically, here is how the files are stored in the iCloud. They're split into chunks, and the chunks are grouped into the containers. And there is a special map that describes what files contains from what chunks. The purpose of that is make the backup more compact, because there is quite a lot of files that contain duplicated data. And so this way the backup actually is stored much more compact than the complete backup. So after analyzing the backup protocol, how the restore is being done, we have found that there are a few comments. First of all, we have to authenticate using the Apple ID and password, and we get the authentication data. Then we send another request called get account settings using the authentication token we got on the previous step. And then with the next comment, we get the list of backup IDs for the given Apple ID, because you can have multiple devices connected to the same Apple ID. And then for every of those backups, we need to send another comment to get the encryption keys. For every backup, for every device, sorry, we then enumerate the snapshots. What are snapshots? Actually, iCloud stores not just the single backup in the cloud, but three last backups you ever made. So if you are doing the backups on a regular basis, that will be backups from today, from yesterday, and from the day before yesterday. Backups are incremental, so only the changes are stored, and so the first most complete backup will be almost the same size as the device size. The second will be much smaller, and the third one will be much smallest. And then we retrieve the authentication tokens for all the files and get the exact location for the file chunks using another command. And then we retrieve the chunks itself. And you probably please pay attention to that actually the chunks are stored not on Apple service, but on Windows Azure, on Microsoft, and on Amazon services. And in our experiences, for the same backup, for the same device, some of the chunks were stored on Amazon, and some of them were stored on Microsoft. And we still don't have an idea whether every backup is stored on both locations completely, just like for fault tolerance or whatever, to make it safer, or the backup is divided between those two servers, and only half of the backup is stored on Amazon and the other half is stored on Microsoft servers. Here's how the encryption of backups is being made. Actually, the encryption keys are stored along with the data. I can't understand what kind of encryption is that if the encryption key is together with the data. It's out of my means. And here is the pseudocode. The encryption itself is good. It is based on IS 256 bits. And encryption is being done by blocks. But we just get the data from the block. And by particular offset, we get all the data needed to get the encryption key, and then we encrypt all the data the same way the device does that. So, briefly, a summary of backups information in the iCloud. As I said, all the data is encrypted there, but there is no definable encryption. You cannot set the additional password on the backup like you do that for the local backup, but only for iCloud one. And Apple obviously has the encryption keys for all this data. And some information in backups are encrypted additionally with the other keys, but they're also stored with the data. The only thing we cannot decrypt from the iCloud backup is the keychain itself, because it is encrypted using the hardware key, which is unique for your particular device. And the other thing is that when you restore the device from the iCloud backup, once the restore process is complete, you receive the notification by email connected to this Apple ID that this particular device has been restored from your backup. If we download backups using the protocol I briefly described, there is no notification and no messages. And so once we introduce that in our software, most users of this software to retrieve backups wives and husbands looking at the backups to retrieve their communications of their spouses and so on, and also the special forces, of course, and forensic people. Next, Find My Phone. If you enable this service, but most users do enable it just because if you lose your phone, it will be much easier to find it, and you'll be also able to send a notification to this device asking to return it, and you can remotely delete the device. And also, the person who found it or who stolen your device will be able to reset the device until he disconnects it from the Find My Phone service. Now with the iPhone 7, if you disable the Find My Phone service, you're prompted for the password to your Apple ID. Exploring the Find My Phone protocol was much simpler because we just capturing the traffic from the iCloud.com and decrypting it by also installing the proxy, and found the simple commands to get the location. First it is validate, and then it is login using the Apple ID and password. And then there are two commands to retrieve the location. First it is just init client, and then refresh client to retrieve the latest location. With the first command to get the location, the older location is being retrieved, which may be up to six hours old. And if you send a command refresh client again, you'll get the current location. Please note that if you'll send those commands frequently to get the location, the battery of the iPhone will be drawn very fast, because GPS service consumes much power. And when the location is retrieved, the Apple server is sending a special push request to the device, and device returns the current location. Then iCloud Documents, which you can use on iPad or iPhone or other iOS-based device. Here is the control panel. What we are doing to get the files from the cloud. Again, Apple doesn't provide any means to get the files from the iCloud. First, we are making the authentication request. It is very similar to one which is performed during the backup retrieval. In return, we get the authentication token and the ID. Then every file is also split into chunks, almost the same way as in iCloud backups. And the output from this command is the list of the chunks with the exact addresses and the information of every chunk. For iWalk documents, for Keynote pages and numbers, the files are stored in the iCloud not as a single file, but as a package. If you go to iCloud.com and try to download any file stored there in iWalk format, you'll be offered two options. You can download in a native format. You can download it in Microsoft Office compatible file format or in PDF. And the conversion is actually being done right on the server. Every file for those three formats is stored as a plist, which is like an XML file, and the actual contains the database with the text and media files, pictures, videos, and whatever. And again, to retrieve the file, we first send a validate and login commands, and then we can send the export command. The export command works only for packages. And as a parameter, we set what particular format we want to export the file to PDF, to native format, or to Microsoft. And then we just need to wait, and from time to time, they send a command to check the export status. And once the export is complete, we can download the converted file. It is temporarily stored on the server. For the latest version of iWalk, there was some changes have been made, and even on the Mac computer, the files are stored like in iCloud, like a container with many files, and they could be password protected, but the hash of the password is stored in in a file with a predefined name. It is also uses PBKDF function for SHA-1 with 100,000 operations, so it is virtually not possible to break the encryption. Next, the iCloud keychain, probably the most interesting part, which was introduced in iOS 7. Once you enable the iCloud keychain on the iPad, iPhone, on a Mac computer, you first being asked for iCloud security code. By default, the security code is offered, iOS 7 offers you to set the same security code as your device passcode if you enable it on your iOS device. You can, of course, use a different security code, but still, by default, it is only 4 digits. And if you click on the more recovery options, you'll be offered to set the alphanumeric password. You can actually skip this step and don't set the security code at all. This way, you'll be able to enable the iCloud keychain on the other devices using only two-factor authentication. You have to select one like trusted device, which will be used to send you SMS notification from Apple service. And every time when you tune the new device to use the iCloud keychain, you'll be prompted to enter the special codes which is being sent to you by SMS. So without security code, your system is safer. But think about that, what is going to happen if you lose your trusted device? For example, your main iPhone. You lose your iCloud keychain completely. So we assume that most people are still using the security code to be able to retrieve your keychain, even if their main trusted device will be lost. You see that when I set up the iCloud keychain on the Mac, there is a small note that if there are no other devices are available, use your iCloud security code to set up it. And it seems that in the iCloud keychain is stored much more information than in a usual keychain. Once I set up it on my device, I have found a few passwords I thought I never stored in my system at all. I don't know why. If you're doing, if you set up the without the security code, once you set up the iCloud keychain on the new device, as I said, you'll have to enter the verification code which is sent to you by SMS. But also, when you enable the keychain on all other devices which are also connected to this iCloud keychain, there is a pop-up appears, as you can see on the right screenshot, with the question whether you should allow this particular new device to use the keychain. And if you press allow, then there will be no need to enter the security code or verification code on the main device, because the push notification is being sent to this device. Yeah, here is the screenshot again. And so briefly, how we have explored that. Obviously, it is really hard to go inside the iOS, especially if it isn't jailbroken. And so we have mainly analyzed the iCloud keychain functionality on the Mac. It contains of several services and diamonds and so on, which retrieves information from the iCloud, sends authentication requests, make additional checks, store the keychain retrieved from the iCloud in the local cache, and then merge them with the local keychain. Here they are. One of the processes interacts with the iCloud control panel. It's called remote service. The SBD diamond is what it is doing the caching and restoring the keychain, and also it gets notifications once the iCloud keychain is being modified on some of the other devices. The Lucky 2 daemon talks to the iCloud. It gets requests from SBD daemon and make queries to the iCloud and receive the responses for them and decrypt them and pass them back to SBD daemon. There is also a SecD diamond for caching and restoring the keychain and get notification. And Kext driver, which is a kernel mode driver working in the macOS system, which works with the key-value storage. And security framework, and also the library for which implements the encryption and decryption functions. So what we try to do, and actually we get a success, we try to retrieve the keychain contents using only the security code, so to work around the two-factor authentication. First, we send the get account settings command using the authorization is being made as an Apple ID plus the password wrapped using the base 64. Then we make a sync query to get the keychain and the key back. The keychain is encrypted using the key stored in the key back, and the keyback is also encrypted itself. But you can retrieve both of them even if you don't have the security code and the other device to get the SMS notification with the verification code and so on. But both of these data, keychain and keyback, are encrypted, so they're useless without the encryption keys. Here is the comment we receive in return to the previous request on the sync command, and we also get the data with the base 64 encryption. But then we need to send a command to verify whether the SMS verification is needed for this particular account, and it is a command called get SMS targets, and what it returns, and the other comment is enroll request phone number, and so we can also retrieve the phone number used for that SMS verification. And with the request, with the response to this comment, here it is, we can see that yes, for this particular account, we need to generate the SMS challenge and also the length of the challenge or of the response that will be sent to the trusted device. Then in the next step, we send SRP init command to get the keyback key. This is the key to decrypt the keyback, which we retrieved on the previous step. And as you can see, you will have to, if the SMS challenge response is enabled, you will also have to provide the server with the response we received on the trusted device. And finally, the keychain recovery itself is retrieving the keyback key. And this is the final step. And using that key, we decrypt the keyback, and using the keyback data, we decrypt the keychain itself. And almost the same as with the iCloud backups. When the backup is restored, I told you about that, on the new device, the notification is being sent on the device. If you use the functions and the request by yourself, there is no notification at all. The same with the keychain. When you enable the keychain on the iCloud keychain on the new device, all the other devices immediately show the message whether you have to allow this new device to use the keychain. If you use the protocol as described before, there is no notification at all, and so you can silently retrieve someone's keychain. But of course, you have to know the Apple ID, the password, and also the security code. And the keychain encryption itself is not really hard using the data we received. First, there is the class of data stored. There are two classes available. One is a GenP class, which stores the Wi-Fi passwords and credit card data. And second is INET class for saved Safari passwords, for the password-protected websites, and also for autocomplete the password fields. And we get all the data we needed to generate the ISK and then decrypt all the data. Here is a brief pseudocode for that. Unfortunately, we tried to perform the brute force recovery on the security code because mostly it is, in most cases, it should be 4 digits only, but only after 5 requests with the invalid codes, the account has been blocked. And to unblock it, you need to call the Apple support. But I said unfortunately because we failed to do that, but obviously it is good for security reasons. So the conclusion on the iCloud. You always have a balance between the security, privacy, and convenience. If you Apple was able to make it more secure, for example, for implementing additional encryption of the iCloud data, but that way it will be not so convenient probably. And so you can get only 2 of those factors out of 3. And so it is your decision whether or not to store your data on the iCloud. It's also about backups on your documents and the iCloud keychain. And now we know that Apple has access to most of this data. And so we're not sure who else has access to that. Probably Amazon and Microsoft as well. And if you trust them, that's your choice. And also probably NSA has access to that too. There is quite a lot of work ahead about the photo stream, about the photo sharing, about how third-party applications data is stored in the iCloud, and how to back to my Mac is implemented. And also probably the most interesting thing about the Apple Touch ID. Apple says that it never stores your fingerprint data, but we never verified that. I'll also briefly tell you, I don't have much time left, about Windows Phone backups. There is no complete backup available in the cloud, but you can use synchronization to sync your notes, your contacts, SMS messages, and so on. And so we cannot extract the full backup data from the app, from Microsoft servers. We can use the Microsoft Leaf SDK to extract most of this data. There are 3 kinds of API. Identity API to get the basic information on the user and on the device. There is Hotmail API to work with contacts, calendars, and events. And SkyDrive API to work with files, documents, photos, and videos. In general, work with all this kind of data is almost the same. We perform the authentication first and to get the authentication token. And in the bottom right corner, there is the steps we need to do. First, we request the folder hierarchy. All the data is stored on the Microsoft servers in folders. And then we can retrieve, we should retrieve the sync keys for all those folders. And for every folders, we send a command to retrieve the number of items for every of those folders. And here are standard folders available on Microsoft for the, that's, you can see not only for mail, like inbox, drafts, and so on, but also for tasks, notes, calendars, and so on. And so basically all the commands are the same, it just change the ID of the folder and to get all information out of there. The only difference is that to retrieve SMS messages, there is something else. There is 1 or 2 extra steps you have to perform. After retrieving the, making the folder hierarchy and sync case commands, the same as for notes and books and so on. We send the categories items command and then get items estimate to get the numbers of SMS, and then there are special commands called get SMS to retrieve the next message from the which is stored on the cloud, and then we need to send the get closed SMS to retrieve the new synchronization key. Retrieving the mail has been performed by actually sniffing the protocol once you go to windowsphone.com. And it is also quite simple. Authorization is a little bit different. We also send the leave ID and password and get authentication token and get the post request, and it redirects to the other to the other location with some other address which we will have to send a further request to. And when we just send a get command with next email ID and to retrieve it contents. There is also a Find My Phone feature. It is probably even a bit more advanced than one available for iOS. We can also get the phone location. We can make the phone ring. We can log the phone and show a message, and we can erase the phone. Also, the authentication is needed using the leave ID and password. But there are some interesting things about that. If device isn't found when you send the request is still cached on the Microsoft service. And once the device will become available, the owner of this account will get an email in return that this device now is available in the network with these coordinates. And so if you are spying over someone else's phone, and if you send this command and the device is not available now, when it will become available, this person will know that someone has been requested his location. Also, if there are a few devices connected to the same leave ID account, we need using a special command to set like an active device, a current device we are working with. And this change is being saved on the Windows server. And so again, if we change this current device, which is currently there, the person will probably not know that once logging into windowsphone.com. And finally, the number of requests to get the location of the device is limited per day. So on the next request, I don't remember after how many of them, probably 10 or 15, you'll get a response that you have reached your limit of the queries. And finally, about BlackBerry backups. BlackBerry doesn't allow to save backups to the cloud, but using the BlackBerry desktop software that was available for all the BlackBerry devices, you were able to create the local backups almost the same way as with iTunes. The encryption with the BlackBerry desktop software versions 5 and 6 was simple enough, especially for version 5. The password verification contained just one SHA iteration, and the speed of recovery of the password were millions or even tens of millions. With BlackBerry Desktop 6, probably after release of our software for cracking all the backups, the BlackBerry has improved that and made 20,000 operations, and so you can crack the backup only on the GPUs. But with the BlackBerry 10, everything has changed completely. Now backups are created with the other software called BlackBerry Link. It also creates a local backup with tar files inside with all information is there. But all these files are encrypted. You don't set the password itself to BlackBerry backups. But the password, or actually the encryption key, is stored inside the device in a special cache storage. And this encryption key for backups is unique for every BlackBerry ID. And it is generated by BlackBerry service at the time when you activate your device and create your BlackBerry ID at the first time. So you won't be able to read the contents of your backup at all. You can only restore it to the same device or to the new device. And moreover, to restore from this backup to the new device, you'll have to set up this new device with the same Apple ID first. So the same encryption key will be generated on the device and stored there. And the encryption and decryption of the backup is being performed by a special service running on the BlackBerry itself. Here is how we have done it. BlackBerry 10 is based on the QNX operating system. Backup is encrypted with AES-256. and authentication of the backup using the hash terms is performed using the HMARC SHA-1. And most of the work being done by the backup arch service running on the BlackBerry. And the encryption is also being done inside the device using the Scramble service. So you can reverse the BlackBerry Link software running on the desktop, but you'll see nothing there. Just send a comment like, give me next backup block, or here is the next block to you to restore on the device. All the data inside the BlackBerry Link is encrypted, and all the encryption is running on the BlackBerry itself. And Scramble service is probably the most interesting one. It is using the BlackBerry ID. And the encryption key used to encrypt the device is called QBAC, and it is stored in the cache storage. And if the encryption or decryption service doesn't find this encryption key in the cache storage, it makes a request to a special so-called secret BlackBerry service called Olympia. First, we need to make a request to the BlackBerry token service to receive the token. And in return, we receive a few data, server entropy, authentication token, and the special ID to be used in the BlackBerry cloud services. And then, to get the actual encryption key, we need to get authentication token, and then the next one, then get the request, send the request to for authentication QBAC token. Then we need to register the device on the BlackBerry server. Actually, there is more than two parameters, like a BlackBerry ID and a password to BlackBerry ID to get the QBAC. The third parameter is needed is the PIN. PIN is an unique ID of the BlackBerry user being used, for example, for BlackBerry Messenger. And we have found that we can send any PIN to this request along with the usual ID and password, but it should be a valid PIN. When we send a request with an invalid PIN, which doesn't exist, we receive an error in return. But still, using the any PIN, but with the same Apple ID and password, we always receive the QBAC. So QBAC is probably stored on the BlackBerry service connected to the every Apple ID. Here is the the structure how it is being done. It is an Olympia service. As I said, it is not, say, publicly available and not mentioned in any documentation. And it is a user cache and a key cache in the device, and it sends requests to Olympia service. And BlackBerry Link just translates those services and receive responses for them. And the QBAC key which we receive is being forwarded to the Scrambler service, which encrypts and decrypts the data stored in the BlackBerry backups. So that's all. I also wanted to say thanks to the people from our team who really helped me with the research on all those topics, and there are 9 people except me who are taking part in that research. And thank you all for listening. If you have any question, you can catch me over there. Thank you.